Hi everyone, welcome to lesson 6 today. This lesson is the last lesson in our series for rationals. So today's lesson is called Connecting Graphs and Rational Equations. So basically when we have a rational equation, we want to find the roots, which are all the solutions to the equations. Roots can also be called zeros or x-intercepts. Basically, we're looking for all x values of our equation. Here is a process to solve these equations algebraically. I'm going to be showing you a process today, instead of solving it algebraically, how to solve it graphically. So I'm going to do it graphically first, and then I will do one algebraically. And for the majority of today, we'll be doing solving by graphing calculator, just because it's a bit faster. So graphically first, and then algebra second. So graphically, I load up my calculator here, and what I'm going to type in into y1 is everything I see. So I see x, I'm going to go plus. I can build a fraction either using my fraction function here on my graphing calculator or using brackets. Both will get you to the same thing. I like this fraction function here on the TI-84s only because it does speed things up a little bit. So that's my y1. My y2 is 0 because on the other side there was 0. I'm going to hit graph right away, and I'm basically looking for where these two graphs cross. So to find where they cross, go second trace option 5, and I'm going to bring my cursor over to where I think the first one is, hit enter 1, 2, 3, and there we go. That's our first answer. I'm going to do this one more time on the other intersection on the right side there. So second trace option 5 again, and moving my cursor all the way to where I think it's crossing. Again, it's crossing around here, so hit enter 1, 2, 3, where you think it is, and there we go. That's our second intersection. So right away, we have two answers, x equals -1 and x equals -4, or sorry, x equals +4. And so because these are my two answers, I'm going to try my best on my graphing calculator to match, or not on my graphing calculator, I'm going to use my graphing calculator to get these answers, then I'm going to match it up algebraically in this example here. So let's take a look at our steps to solving this algebraically. Factor denominators only. If possible, find the LCDs, state restrictions, multiply LCDs to every term, cancel out denominators, simplify, and check for extraneous solutions, of course. So, very first thing I'm going to try. So what I could do is, right now I have denominator of x plus 2, and I only have one of them. Everywhere else in this question has a denominator of, everything's always usually divided by 1. So I have divided by 1 over under that x, divided by 1 under that number there, and technically that 0 should be divided by 1 as well. So what I could do is I can make a common denominator right away. That would work. I can move things to one side, get rid of the denominator, and then move things back. That would work as well. It's really whatever you're comfortable with doing. I know that I have an LCD. If I look at my denominator, my LCD, lowest common denominator here, should be x plus 2. So I'm just basically going to multiply everything in this equation on both sides all by x plus 2. So if I multiply it all by x plus 2, I end up with x plus 2 plus 6. And my x plus 2 that I LCD multiplied by this x plus 2 here will cancel out. So it's just going to be plus 6 by itself, minus 5 times x plus 2. And of course, that's going to be equal to 0. And 0 times x plus 2 is still 0. So it doesn't really do anything there. Here I'm going to multiply everything out. So I have x squared plus 2x plus 6 still there in the middle, minus 5x minus 10 equals 0. Simplify, collecting all like terms, we have x squared minus 3x, and we have minus 4 equals 0. And of course, factor, or however you want to solve for x here. I like factoring, so I'm going to factor this out. So this is x minus 4, and the other side, of course, is going to be x plus 1, and both are equal to 0. And because we have our factors here, I'm going to set each one individually equal to 0. So we have x minus 4 equals 0, so therefore x is equal to positive 4. And over here we have x plus 1 equals 0, and of course x equals negative 1. And there we go. Our two solutions that we solved algebraically match up to our two solutions on our graphic calculator. So we should be good. So I'm just going to put a quick box around each of these to denote that they are my solutions. And that's what I was looking for. The one thing we haven't really talked about here is we should state a restriction after we figured out our LCD. Our restriction is always in our denominator. So what's in our denominator? It's x plus 2. So my restriction, I'm just going to do it off to the side here, is equal to x plus 2. That whole denominator cannot equal 0. So really x cannot equal negative 2 there. So negative 2 was my restriction. X equals negative 2. So that's the first one. We solved it algebraically. From here on out, I'm just going to solve everything else graphically. It does speed things up a little bit. So graphically, here we go. Straight to my graphing calculator again, clearing off what I have on the screen here and typing in my equation. So the first one I have is going to be 2 minus, and again, if I have a fraction, I'm going to use my fraction function, and I have 3x. So let's try that again, 3x, and that's going to be over 2. And my second equation is going to be 1 plus 4x minus x squared. That's on top of a 4x plus 10. And again, if I have two graphs, I'm looking for where they cross. So there's one graph, there's the second one. And again, to find where they cross, second trace option 5. Second trace option 5. Go close to where you think one of those intersections are. There it is. Hit enter 3 times. 1, 2, 3. And there we go. That's going to be my first solution for x. So x is going to be this ugly decimal. That's perfectly fine. We're allowed to have decimals. That just means, though, FYI, that our answer probably should be in exact values if you were solving it algebraically. So meaning that there should have been a radical in our answer. For my second one, there we go. Also an ugly decimal, but that's okay. But yeah, here's my second one. And there we go. We have both done and on the screen for you. In example 3, the same thing here. I'm just going to try my best to type it into my graphic calculator and find where these two equations cross. So on this first one here, second, I have 2x minus 3 in my numerator. I have an x minus 3 in my denominator. All of that's still going to be subtracted by 2. Then in y2 there, I have 12 in my numerator. And then I have my x plus 3 in that denominator there. Perfect. I'm going to hit graph. And it looks like here we only have one answer. It looks like it's only crossing once. And of course, if I don't have my cursor there, just keep hitting your right arrow until you get there. And yes, we only do have one intersection, and it looks like it does intersect only once here at 5. And I don't care about the y value, I'm looking at x only. Some people always ask me in class, what if there was a second answer to the left there? How would you know? Well, the other way that you can graph this to double check is if you took that first equation, don't do anything to it, and move that second equation right beside the first one. So I'm going to subtract off my second equation. So that was 12, and that's x plus 3. So that means in y2, I don't want that second equation there. I actually want 0. So I moved everything all to one side, and here's this graph here. So basically this graph I'm looking for is where does it cross the x-axis. Again, I only cross the x-axis once that I can see. And so that should prove that we only have one solution. And again, it should be the same. So right now you have two different ways to get to the exact same solution. There we go. Here, this is just notes on how to set up the graphic calculator. Again, we just did this, and so I'm going to skip this one here, this example here. We just did that on a graphic calculator. That was the same as the previous example B. This last one here, we will try to type into our graphing calculator. Again, I'm going to show you it in two different ways. So the first method is type in what you see on here as is. So I have in my y1, um, this one here, I have this x plus 3, and then I have my 2x, it looks like minus 6 in the denominator there. On the second y2, I'm going to go with 2x, and that's going to be all subtracted by, we have an x in the numerator there, and 3 minus x in the denominator. Hit graph, and let's see what happens. So there we go, we got one graph basically. Okay, so again, tough. How many solutions do we have? Let's find the one that we definitely see. So there we go. Our only solution we have looks to be at x equals -1/4. Again, a lot of people ask, what happens if it crosses down here on that far right? How do you know that it didn't cross there? Well, again, what should you do? Set all your equations equal, all to one side somehow. So in this case here, I'm just going to move this equation here. It was positive. I'm going to move it to the end of this second one here, or vice versa. You can move it to the first one. It doesn't really matter which way you move your equations there, folks, as long as everything's all to one side. And then, so that means if I moved it to the end of the second, everything here has to be cleared out, and now I have 0 here. Hitting graph, I have a straight line, it turns out to be. Second trace, option 5 again. And again, the same answer as our previous graph, but this time it's just graphed slightly differently. But it is the same answer, same x values on both. And that is the end of lesson 6. Again, it's just getting comfortable with your graphing calculator. Be aware that, hey, there's two different ways that you could have typed this in. Either a y1, y2 way or option, or you could type it all in as a y1 with a 0 as a y2. So totally up to you. Again, if you have any questions, please feel free to email me or ask.